All right, so we're going to perform image similarity search using embeddings and FAISS vector database. But before you get started, make sure you have the necessary images, which you can find from my GitHub repo. I'll be using a bunch of simple images of animals, vehicles, and landscapes for the demonstration. So coming to the code, we start off by importing the necessary libraries such as pandas, numpy. We'll be using PIL, which is Python imaging library, in order to manipulate images. It's a fundamental library in Python for image processing tasks. We'll use Torch Vision, which provides utilities for loading datasets, pre-trained models, and image transformation tools. FAISS, as we know, is a vector database, and Torch is the core library for PyTorch for tensor computations. After we import the necessary libraries, we set our device to CPU. Now, this is important to ensure that all the tensor operations are performed on the CPU, especially if you do not have GPU available or if you don't want to use GPU. So I create a simple data frame using images and their categories. I'm using 4 images of animals, vehicles, and 1 for landscape. So let's run this code block. Now let's do a df.head, and that's your data frame. Next, we perform a series of transformations or steps, such as image loading, image preprocessing, and a model which will create embeddings for each of these images. Now, transforms.compose defines a series of image transformation steps using transforms, which is a part of or a module of Torch Vision. So we begin by resizing the image. We crop the center part of the image. We convert the image from PIL format to a tensor format, which is the required format for PyTorch models. And finally, we normalize the image by defining the mean and standard deviation. Now, this mean and standard deviation values are to ensure the image is on a similar scale to the data that this model was trained on. I've defined a function called loadImage, which just loads the image from a specified path. Next, we define a model using ResNet 50, which is a pre-trained model, and it's a popular convolutional neural network that has been trained on a large data set of images. And this model can extract complex features from images. And finally, we set the model to evaluation mode. So let's run this now. All right. Next, we define a function called getImageEmbeddings in order to generate an embedding of an image using a pre-trained neural network model, which we've loaded in the previous code block. So let's define our model, and the next code block generates a corresponding embedding for each image, stacking them into a single numpy array, for which I've used numpy.vstack. Let's run this, and now let's have a look at the shape by using embeddings.shape. So you can see we have 4 images, which is why the value 4. And these images have 1000 dimensions each. So now we're going to use another image called landscape 2, which is right here, which is not a part of our data frame, by the way. And we'll do a similarity search in our vector database using this image, which is landscape2.jpg. So we load the image, get its embeddings, and convert it into a vector form. And finally, we do an index.search by passing the search vector, which is nothing but a search image, landscape2.jpg, and the value of k is set to 4, meaning we want 4 vectors that are similar to our search image vector. This is exactly what we did for the text search also, right? So let's run this code block and see the output. All right, so it says index is not defined, which means I have to run the previous code block. And now there you go. So you can see the output has 2 arrays. The first array contains the distances of the 4 nearest embeddings or the images from the FAISS index. And the second array contains the indices of these nearest embeddings in the original data set. Now, if you want to print out the results in a more readable format, you take the first row of the indices array, I, from the search result, and using this, you retrieve the corresponding rows from the original data frame. So let's run this to see our final results. All right, so you can see This basically means the embedding at index 3 in our dataset is the closest match to your query image, which makes sense because landscape.jpg is closest to landscape2.jpg. Now, landscape.jpg, as we would imagine, is an image of a landscape. So is landscape2, but these are different images. All right. So that's how you perform embeddings and image search using FAISS vector database. I would encourage everyone to try this code out using a set of completely different images and see how this works for practice.